Okay, so the directions on the 33 say that we're supposed to factor this, and they're not trying to trick us with any in this section. They actually all are factorable. The thing about it is you got to remember something in order to even know what to do here. First of all, you've got to check for a GCF and see if you can get something out of there, because right now we don't see any perfect squares in 8 or 2. But what if I took the GCF out? Doesn't 2 divide out of all those terms? 2 divides out of 8x squared, 4x squared times, and I'll put my plus. If I take the 8x and divide it by 2, I got 4x. And if I've got 2 and I divide it by 2, I've got 1. I have to put that 1 there. I can't say 2 divided by 2, oh, it goes away. No, I got to put the 1 there. Okay, now, what I need to do is I need to work on the part inside the parentheses. I do have to keep up with the 2. Each step has to be equal. But what I'm looking to see is how can I factor this? And I know it's in a section on perfect square, so it's going to be a perfect square. There's going to be a square here and a square here. If I can factor this as a perfect square, it's not a difference of two squares. It's called a perfect square trinomial, which is a big long word. But basically, we're saying that this is a perfect square that has 3 terms. Okay. So let's think about it. For the 4x squared, what could you square to get 4x squared? Well, you could square 2 to get 4. You could square x to get x squared. So, since we can see from the instructions this is going to factor, we know that if this is going to be a perfect square that factors, that first term already is going to be a 2x. Okay? Now let's go look at the last term, because remember it's the first term and the last term. We have to put it in standard form. This one was in standard form. This one wasn't one where they were trying to mess with us like they're going to do on 35. That last term is a 1. What can you square to get 1? Oh, you can square 1. It's a positive 1. Now there's 2 ways to get a positive 1. You could square a positive 1 or a negative 1. So I go check the sign over here. Oh, it's positive, so I want this to be a positive 1. So it looks like this is going to factor into 2x plus 1 squared, but let's just make sure, because the only reason I knew it did was that it said factor it, and I noticed there's there's none here that don't work. Why does this work? Because 1 times 2x is 2x. And remember, I multiply this 2x and this 1 together, and I get 2x. And then I have to double it. What's 2 times 2x? 4x. Is that what's in the middle term? Yes, it is, right there. So this does factor into 2 times 2x plus 1 squared. They were messing with me a little bit. And actually, you could factor 35 in the order they give it to you, but I'm going to go ahead and just try to get you to build some good habits here that will pay off later on other problems. They gave me this problem. I noticed, remember I told you standard form is where you write the term that has the variable with the biggest square on it first. So I'm going to first rewrite this as 144m squared. And then you write the next, you look for the term that has the variable, but the next power down, or a smaller power, and that's this negative 72m. Remember, we have to take the sign out front. The subtraction sign is that we have to keep it with that 72. And then we have a 9. The plain old number, the constant, always goes on the end. Now, if this is a perfect square, it's going to factor into, something like this. In order to see if it works, we know it works because instructions said factor them all. We're going to have to say, what do you square to get the first term? What do you square to get the second term? And let's pretend they said that maybe some of them wouldn't factor. We're going to talk about how would I know that it actually did work. So let's start. What do you square to get 144m squared? Well, to get 144, you could square 12. To get m squared, you could square m. So if I have a perfect squared, that's going to go right there. Now, go to the number on the end. What could you square to get 9? 3. Actually, you could square 3, or you could square negative 3. How do I know which one I want? Oh, there's a negative here, so it's got to be a minus 3. So if this works, it will be 12m minus 3 squared. Now remember, how do we check out this middle term here to make sure that it actually did factor and they weren't trying to mess with me and give me something that wouldn't factor? If you remember what we do is we say we multiply the 12m times the negative 3, the two things that we wrote in our parentheses, that would be negative 36m, but I got to double it. Because remember when we multiplied them out, there were 2 copies of this sitting there when we multiplied them out. 2 times negative 36m is negative 72m. Is that what we had up here in the middle? It sure was, so we know we factored it correctly. When you see how hard it would be to factor this the normal way, you will kind of learn to appreciate this perfect square form. Okay, 37. 37 is x to the fifth plus 2x fourth plus x cubed. Okay, now, first of all, before I try to mess with this, I need to pull out a GCF if there is one, and sure enough, there is one. This x to the fifth, x to the fourth, x cubed, I see x's in each one, and I see that each one has at least 3 in them. So my GCF is my x cubed. It's a cube there. It's kind of hard to read. And if I divide that out, x to the fifth divided by x cubed, remember if you get confused here, you could always go do this, and remember your exponent rule says subtract the exponents. 5 minus 3 is 2. So this would be an x squared. Now, if I divide x cubed out of 2x to the fourth, there would be a 2 left, and if I subtract my exponents, 4 minus 3 is 1, so it would be an x to the first power. Now, I'm not going to write the 1. X cubed divided by x cubed is not nothing. X cubed goes into x cubed one time, x cubed goes into x cubed one time, 1 over 1 is 1. You've got to put the 1 there, okay? Just being careful there because I know that ends up confusing people a lot of times. Now, if this is a perfect square and it factors, I'm going to have, here's how I know it, if it will. I look at the first term. Is there something I can square to get x squared? Yes, I can square x, and that would go here if it works. And then I go look at the last term. Is there something I can square to get 1? Yes, 1 or negative 1. How do I know I want a positive 1? This sign right here is positive. So it's a plus 1. X plus 1 squared. Now, how do I know this worked? Remember, how do I check it to see if it actually really did factor this way? I say I take the x and I multiply it by the thing over here, the thing's inside the parentheses. 1 times x is x. But when I double it, when I multiply it by 2, I get 2x. Is that what I had right here? Yes, it was. So I do know that it factored correctly, that I factored it correctly, and it really did factor this way. If there had been anything up there other than 2x, it would not have factored out correctly. And so I couldn't have written this answer. And we'll do 39, the last one on this video. 39 is a squared b plus 6ab squared plus 9b cubed. Okay, let's check for a GCF here first. Let's see. We need to get that out. We look at it. Everybody's got a b. Almost you could divide a 3 out, but that first term doesn't have a 3 with it, so let's divide a b out. That's my GCF. I have to write it down. I have to have equal expressions on each line. That would be an a squared left. If I took a b out of 6ab squared, the 6 would be left over, the a would be left over, and there'd be a b. If I took a b out of 9b cubed, the 9 would be left, and then, remember I could say that's a 1b, 3 minus 1 is 2, so the exponent on the b would be b squared. Okay, now, if this works, and I'm going to come down here, if this works, how am I going to know it? I'm going to look at the first term. Is there something I can square to get a squared? Yes, I can square a, so that would go here. Then I go say, okay, if it works, what could I square to get 9b squared? Well, to square 9, I could either square 3 or negative 3. I'm going to put 3. The reason I put a positive 3 is there's a plus sign right here. And then what I square to get b squared, it would be a 3b. So that term, plus 3b, would go here. Now, how do I know? I got to put the square here. How do I know it really worked? You remember how we checked to see if it really did factor, and then they're not trying to trick us. We take what's inside each parentheses, the a and the 3b, that's 3ab, but then we got to double it. 2 times 3ab would be 6ab. That must match my middle term, does it? Yes, it did. So this actually is the correct way to factor it. And we figured it out. We knew there weren't going to be any in there that didn't factor because they kind of told us that factor, which assumes that, that all of them are factorable.